Assalamualaikum and hi, my name is Fatih Zati binti Khairul Isham from class J4 EM1105P. Today I will be explaining about the proposed air conditioning system for the mini project. Now let's start with the first part, which is introduction. Let's start with the building description. The house is located in Bandar Tua Razak, Cheras, Kuala Lumpur, and it is located near to the main road, industrial area, shops and construction site. The purpose of installing the air conditioning system for this house is to improve the air quality inside the house by installing suitable air conditioning system and to have a comfortable home without having trouble with hot temperature inside the house. This is the floor plan selection for the terrace house. The height of wall will be 8 feet and the walls will be brick wall with cement plaster on both sides, and the glass will be dark brown inside blind with external shade. The material for the door will be plywood door, and the dimension of the door will be 4.6 feet, 6.6 feet. The ceiling will be common suspended board ceiling. The floor used will be concrete floor. The roof will be using corrugated asbestos. And the total area for the floor plan is 1,000 square feet. Now comes to the second part, which is the methodology. In this part, I will be explaining about the method for calculation, the procedure, and the assumption of design. Now let's look for the method for calculation. The first method is cooling load temperature difference. The first method for cooling load estimation. For this method, it is a method where the corresponding temperature difference used to measure the temperature difference, immediate external cooling load over a wall or roof, the outside temperature differential, daily temperature range, solar radiation, and heat storage in building infrastructure mass can also be determined by using this method. This method is also influenced by orientation, tilting, month, day, hour, latitude, and others. As you can see in this slide, the figure is showing the example of cooling load estimation table. The second method is the equal friction method for duct design. This method is important in order to choose the main duct velocity and duct sizing consistent with good practice from a point of view for a specific building or application. The steps for this method is first, calculate the value of supply air, CFM, for each room in the proposed house plan. Second, calculate the number of diffuser. Third, find the true radius of each required diffusers. And fourth, plot the graph and find the pressure drop. At the left side of the slide, it is the formula used for this method. Now let's talk about the procedure. The procedure starts with the house plan is drawn complete with its dimension and poles, the latitude. Next, determining the material and dimensions of the wall, windows, door, ceiling, and others. Then, total cooling load estimation for each room is calculated by using the cooling load estimation table. Next, the CFM values for each room is calculated by using the formulas. The number of required diffuser for every room is also calculated by using formula. Next, the true radius, the length and width is calculated for each room by using formula. The house plan with ducting system is drawn later after the true radius has been determined. Then the table of duct system, diameter of the duct, pressure drop of each duct is tabulated. Then the graph of friction loss and equivalent round duct size is plotted. And last but not least, the pressure drop of each duct is calculated. Now let's talk about the assumption of design. As you can see in this slide, at the left side is the bedroom 1 and at the right side is the bedroom 2. For the bedroom 1, the size of the bedroom is 9 times 11 feet and the materials for the windows, roof, door, ceiling, and floor is the same as I have explained in the building material before. The number of packs in this bedroom is 2%. The equipment in this bedroom is bed, table and chair and light. For bedroom 2, the size of the bedroom is 13 times 11 feet. The number of packs in this bedroom is 2% and the equipment in this bedroom is bed, table and chair and light, same as bedroom 1. For living room, the size of the living room is 16 feet times 15 feet. The number of packs in this living room is 7%. The equipment in this living room is sofa and television. For the office, the size of the office is 11 feet times 7 feet. The number of packs is 1% and the equipment in this office is table and chair and laptop. For master bedroom, the size is 14 feet times 14 feet. And the number of packs is 2% and the equipment in this room is bed, sofa and television. For garage, the size is 16 feet times 14 feet and the number of packs 7% and the equipment is cabinets and table. Lastly, for dining and kitchen area, the size is 16 feet times 9 feet. The number of packs will be 7% and the equipment is dining table, kitchen stove and tabletop. Now comes to the next part, which is the result and design. In this part, I will be first showing you the table of cooling load calculation calculated in the assignment from the assignment before by me and my colleagues. This table of cooling load estimation, table is used to find the grand total heat and will be used to calculate for the BTU per square feet, to calculate the CFM and others. So as you can see in this slide, the first table of the cooling load estimation is the dining and kitchen area. Next is the garage, the bedroom 1, living room, the second bedroom, the office, the master bedroom. Now is the grand total cooling load. From the cooling load estimation table, as what I have shown just now, I could calculate the total of the cooling load BTU per hour, which I gained about 92,374.2 for every room in the house plan that I have proposed. This is the house plan drawing with the ducting, complete with the ducting system, using the FCU unit and the diffuser that I have searched from the catalog. For this mini project, the proposed air conditioning system is that I have proposed is the air package unit system by Accent Malaysia. Why I chose air package unit system in comparison to split unit or other air conditioning system is first, air package unit offers more space saving. Second, it has low indoor noise. Since obviously no one likes it to be in a house with noisy sounds coming from the rooftop or from the ceilings. Third, it is easy and economically cheap to install. And fourth is the maintenance could be done in one same place, so it is easier for the technicians to do this work. And lastly, it involves ducting system as per required by the question. The air package unit that I have chosen is from Accent Malaysia, the A series with a model of RART100E, having the cooling capacity about 100,000 BTU per hour. Now comes to the second last part of this whole presentation, which is conclusion. From this whole mini project and last assignment, also from the last assignment, especially for this mini project, I think I have successfully achieved objective of this mini project, since from this mini project, I'm able to gain the total cooling load in BTU per hour for each room in the house plan focus from last assignment by using the cooling load estimation table. Next, I am also able to calculate the supply air, CFM, the number of required diffusers, and its throw radius for each room that I have proposed in the house plan. Next, from this mini project also, I have gained a lot of new information such as the prices, the leading brands, and the benefits of the diffuser starting system and air conditioning system by searching up the catalogs and scrolling out through the websites and the articles. And lastly, I am also able to determine the BTU per square feet and CFM per square feet by using specific formula and compare it to the check figure. Now comes to the last part of this whole presentation, which is the references. This is references that I have used in completing this mini project and this whole presentation. So that's all from me. Thank you.